Pathology is going through a revolution. We're digitizing slides, we're indexing them, and then sharing them with pathologists and using analytics to do diagnosis. However, we're facing significant challenges. We're seeing an increase in the incidences of disease, fewer pathologists are entering the field, and more are retiring. To address these challenges, we turn to technology. What we're seeing is a revolution in digital pathology where we're moving from microscope-based workflows to digital workflows, where instead of looking at a biopsy slide under a microscope, pathologists are looking at them on a computer screen. So where Huron plays is our tissue scope whole slide scanners, and these are instruments that automate the digitization of biopsy slides. The huge problem is that there are hundreds of millions of slides that are generated every year around the world. And even when they're digitized, they're unlabeled. Basically, there aren't enough pathologists to be able to mark every slide. That's really where artificial intelligence comes in. We've partnered with the Kimia Lab at the University of Waterloo.
The mainstream AI is focusing on what we call classifications. When somebody has to teach AI what is right and what is wrong, that's of course very tedious, very laborious. You cannot do that for millions of images. So we went with the image search, which is inherently an unsupervised technology, which means it doesn't need the pathologist to teach it. It just goes into the archive and finds similar cases.
Once these images are digitized, then it becomes easier to access them. The way that we represent the slides as these tiny kilobyte-sized barcodes, you can basically be able to search these images, hundreds of thousands of them per second. And so not only can you look at what's available in your own hospital, but you can look at what's available across the country and potentially around the world.
So what we did, we look at the so-called deep features, which are again some numbers that AI calculates for each image, and we save them as barcodes. Going toward barcodes makes it possible to tag and find histopathology images in a very short time. A file with 1 gigabyte could be reduced to 5 to 10 kilobyte of information.
So the big picture to this is in areas, for example, in sub-Saharan Africa, where you have maybe 1 pathologist per million residents. Imagine if they're able to send a text message size file over a 2G network and compare it to a large archive. It's a huge step forward in terms of democratizing pathology. Behind every biopsy is a patient. It's incredibly gratifying to think about how we're able to make lives better, not only here in Canada, but around the world, because over time, digital workflows will become ubiquitous, and that's a great thing.